Hello students, welcome to Akshar IIT classes. So today we will continue the last topic. So we are discussing about the dot product, scalar product. Okay. So in the scalar product we have discussed definition of the scalar product and properties of scalar product. So today we'll do some problems based on the concept what we have discussed there. So now in the page number 45, fourth practice sheet. Okay. So I'll recall once again what we have discussed in the last class. So a bar dot b bar is the two vectors, then the product of those two vectors. If it is a scalar, then we can say it is a scalar product. Then formula for the scalar product we have seen there. A bar dot b bar is equals to ab cos theta. Ab cos theta. Okay. So then the dot product can be obeys the two laws. They are the commutative law and the distributive law. So commutative law is nothing but a bar dot b bar is equals to the b bar dot a bar, and the distributive law it is a bar dot b bar plus c bar is equals to a bar dot b bar plus a bar dot c bar. That is a distributive law. Okay, and we have seen in the last class the dot product of the unit vectors. So the unit vectors along x axis, y axis, z axis we have seen there. Dot product of two similar unit vectors we got there is it is equals to 1, and dot product of the two different vectors, two different unit vectors that we have seen there it is 0 there. Okay. Now based on that concept we will do some problems from the practice sheet fourth, page number 45, fourth practice sheet. Practice sheet. So here the first question is given. First question, product of two vectors. Product of two vectors. First option is given here. Always results a scalar. Always results a vector. Third option is given. It is not possible. And fourth is given. May result a scalar or a vector there. Okay. They did not mention here in the question product of two vectors. Product of two vectors. So they did not mention that product is a vector product or dot product. So we cannot say it is a particularly a scalar or particularly a vector. So we can write here option 4, we can write it as a maybe result a scalar or a vector. So that product of two vectors, it may be a scalar or a vector there. Suppose if it is a dot product, it will be give the scalar. If it is a cross product, it will be give the vector there. Okay. So the correct answer for the first question is the option 4. Answer for the first question, fourth option, option 4. Option 4. So this is the right answer. Now the next question is given here. If a bar is equals to, second question, if a bar is equals to ax I cap plus ay j cap plus az k cap, ax I cap plus ay j cap plus az k cap, and b bar is equals to bx I cap plus by j cap plus bz k cap. Then the dot product of the two vectors, that is a bar dot b bar. So then what is the a bar dot b bar? A bar dot b bar. So we can write here a bar is here ax I cap plus ay j cap plus az k cap dot bx I cap plus by j cap plus bz k cap. Okay. So we know that in the last class we have seen that the dot product of the similar unit vectors is 1 and dot product of the different unit vectors it will be 0 there. So I bar dot I cap dot I cap will get 1 and I cap dot j cap dot k cap dot I cap, it will be 0 there. So we can multiply here ax I cap bx I cap. So here we'll get there ax bx plus a by j cap b by j cap. J cap terms we need to multiply so that we will get the answer for them, it is 1 and the remaining different unit vectors product of dot product of different unit vectors it is 0. So a by j cap b by j cap. So we will multiply only the similar unit vectors. So that is here we will get a by into b by a by j cap into b by j cap. So j cap square value 1 we will get a by b by plus here next one is az bz will get there az bz. So k cap whole square k cap square is 1. So therefore we will get a bar dot b bar. So a bar dot b bar is equals to ax bx plus a by b by plus az bz. So here it is there in the option first option. So answer is option 1. Option 1 is the correct answer. Option 1 is the correct answer. Okay. So next question is given. Next question. Two vectors are perpendicular if their dot product is. Two vectors are perpendicular if the dot product of those two vectors. So next third question. Let us consider if two vectors are a bar dot b bar, a bar dot b bar, a bar dot b bar. We know the formula. Dot product formula is what there? Magnitude of the product of magnitude of the two vectors and cosine angle between them. That is cos theta. So if they are perpendicular, the two vectors are perpendicular. If a bar dot b bar, a bar is perpendicular to b bar, then the angle between, then theta is equals to what? Theta will be theta between them. It is the 90 degrees, no? 90 degrees. Then here if you write here a bar dot b bar, a bar dot b bar is equals to ab cos 90, ab cos 90. So what is the value of cos 90? Cos 90 value will be 0. So cos 90 is equals to 0. So from this we can write here a bar dot b bar, a bar dot b bar is equals to ab into cos 0 value here, cos 90 value will be 0. So therefore we will get here a bar dot b bar is equals to 0. So the dot product of two vectors, if they are perpendicular to each other, then it will be 0. The dot product of two vectors is 0 if they are perpendicular to each other. Okay. Next question. Next question. Dot product of two vectors is maximum when the angle between the two vectors is. Okay. So then again we can take the two vectors here. Next question, fourth one. If two vectors are given here, the two vectors are a bar dot b bar, a bar dot b bar. So from the formula we can write here ab cos theta, ab cos theta. Now the dot product of these two vectors, when it is going to be maximum, when it will be the maximum. Okay. Then they are asking the angle. So if you write here from this, when this it is going to be maximum there, if you take here, if theta is equals to 0 degrees, if you write there, if theta is equal to 0 degrees, then what happens, we'll see there here, a bar dot b bar, is equals to, we'll get ab cos 0, okay, ab cos 0. We know that cos 0 value, cos 0 degrees is equals to 1, cos 0 degrees is equals to 1. So here we'll get there ab into 1. So we'll get here from this a bar dot b bar, is equals to ab. Therefore here we'll get a bar dot b bar is a ab. AB. A bar dot B bar is equals to AB will get there. Suppose if theta is equals to 90 degrees, then dot product is 0. Just now we have seen there in the previous one. Then A bar dot B bar, is equal to 0. In the previous problem we have seen, no? So it will become, dot product will become 0 there. So now if theta is equals to 180 degrees, then a bar dot b bar, is equals to, what can you write here, ab cos of 180 degrees. So cos 180 value will be, so here since from this cos of 180 degrees is equals to minus 1. So now from this we can write here a bar dot b bar, is equals to ab cos 180 degrees is minus 1. So therefore we'll get here a bar dot b bar is equals to minus ab. So see here we got here minus ab, a bar dot b bar is minus AB, and here a bar dot b bar is equals to AB. This is AB, no? AB. Okay. AB we got here. When theta is equal to 0 degrees, we got here plus AB. When theta is equal to 100 degrees, we got here minus AB. So this value we can write here. This is a minimum value. It is a minimum value, and here we can write this is a maximum value. This will be the maximum. So now from this we can say here, when theta is equals to 0 degrees, then dot product of two vectors, it is going to be the maximum. Okay. So here the option is what? Option is 0 degrees. Option answer for this question option 4th is correct there. Option 4th is correct. Next question. So 5th one, two vectors are added, then the resultant vector is. If the two vectors are added, then resultant will get here vector only. Will get the vector. The two vectors in the last classes, vector addition we have seen there. If the two vectors are added, then definitely will get a vector only. So option is here. For the 5th one, it is option 1. Then 6th one, if two vectors are multiplied, then product is. If two vectors are multiplied, then product is. Okay. So here also they did not say it is a scalar or it is a dot product or scalar product. Just it is a product. Then we can say either scalar or either vector. Either scalar or vector we can say there. Okay. Option 3 is correct for the 6th one. And 7th one, product of velocity vector and force vector is. Product of velocity vector and the force vector. Product of velocity vector and the force vector. So it will be the power. So velocity of force vector and the velocity vector. So this will be see the seventh one. Seventh solution you see there, product of velocity vector and the force vector. So this is a force, F bar is equals to F bar dot V bar. F bar dot V bar is equals to, it will give the power. Okay. So here F is the force, and V is the velocity, V is the velocity, and P is the power. So power formula is what there? From the power formula we will get that equation. Power P is equals to work done by time, no? So again here work done is nothing but work done is equals to force into displacement. Force into displacement divided by time. Force into time. So work done is nothing but force into displacement, no? Then here this can be written as power is equals to, we know force is a vector quantity and here displacement is also vector quantity, divided by T we can write here, now here. So divided by T we can write, this is a displacement by time. So we know that displacement by time is nothing but velocity, no? V bar is equals to S bar by T. So S bar by T is nothing but V bar we can write. So from this we can write here P is equals to F bar dot V bar, we can write there. Now we got here the dot product of the force vector and the velocity vector, it is giving the power. So this is the power there. Okay, power. So here power is equals to work by time, then work is nothing but force into displacement. From that we can say here the power is nothing but dot product of the force vector and the velocity vector. So it is a dot product, then if it is a dot product then result will be the scalar only. Okay. Nice. Now here the correct answer is seventh one. Answer correct answer is option 2 is the correct answer. Option 2 is the correct answer. Next, eighth question is given. The product of displacement and force vector is. The product of displacement and force vector. The product of displacement and force vector. Yes. Now here eighth one. Just now we have seen the force vector and displacement vector. From this only we can say here. Okay, in eighth one, from this we can say, no, so eighth one, W is equal, W is nothing but what their work, this is nothing but product of force vector and the displacement vector, or displacement vector and the force vector, it is nothing but the work. So this will be the work. So we can write here the product of force vector and the displacement vector is the work. So eighth option is correct option. Work done, it is a scalar. Work done. This force power is a scalar. So here the power is a scalar, okay? Because it is a scalar product, no? Means vector product. Means dot product. So dot product results the scalar. Okay, this is a work. Dot product of two vectors is the scalar. So we will get a scalar. Result will be the scalar. It is a scalar quantity. Work is a scalar quantity. Even the power is also scalar quantity. So for the eighth question, the answer is here option